Jai Hind everyone, welcome back to my session. As discussed in the last class, we have quickly compared what are the different methods on which we can use with the list, which are going to be very useful when you are coding your Python program. This will make your program really easy to work with. Okay, so we have discussed many things like what we have done in the previous class was append, we have done extend, insert, count, concatenation, and also we have seen replication of a list. Okay, in today's class we are going to take up some more methods which are there in the list. The very first one which I would like to discuss is the index. I'll just comment it just like I did before. The index method is used to identify the index number of a given element. I'm naming whatever is the value given in the list. Okay. So suppose I say L1 equals 2, and this time let me take it as not just numbers, I'll take it as, let's say, some characters. Okay. Sorry, I gave a comma. Let me take this out. Now when I say L1, it is having a list like this. Now suppose I want to know what is the index at I. What is the index number? Because index number is very important in your list. Okay. So if I want to know the index number of I, then how can I give? I can say L1 dot index of I. Now what does it give me? It is giving me 2. Is this 2? Yes, it is 2 because my index number starts with a 0. So Q is holding an index 0, Y with an index 1, I will be an index 2. So this is how you can identify what is the location of your element in that particular list. Now let's suppose I am making the same list. I'm going to modify. I'm giving another one I here. Now what happens? Now from where does it show? Which is the precedence? Like how exactly is it going to evaluate कि कौन से वाले I की value दूँ मैं? So the answer is it will check out for the first appearance and give the location. If I say this again, it is giving 2. It has not identified 3 and 4. This is a fourth index number. It has not identified this fourth index time. Okay, it will look for the first appearance and it will give you the index number. Now I am making another change. I am making it as capital letter. Why I am reiterating this every time is so that it becomes very clear to you that capital letter I and small letter I have different ASCII values. They are having internal different meanings in them. So it will not be identifying I as I unless and until you have really made some efforts to convert them internally. So I again say L1 dot index of I. Now this time it is going to show me 0, 1, 2, 3, 4. So let's see. Okay. So this is nothing but your what did we see now? We have seen index, the index method. So you can utilize this. We will see the applications. We will see the use cases where exactly it would be utilized. Then we'll be happy to know that my work has become simple because of using these methods. Now coming to the next one, remove. Remove is your next method. Now same L1, I want to remove, let's say, Y. I don't like questioning every time why. So I remove Y, let's suppose. So how do I remove Y? L1 dot remove, and I specifically give the value what I want to remove. So I want to remove Y. Again, case sensitive, please remember small letter is given in the list, so small letter should be removed back. So let me see now, what is it holding? Has it removed the Y? Yes, it has removed Y from here. Right? So remove is used, the remove method removes the element or value, we can say the value from the list. Now just like how append and insert were two different things, appending is also putting a value but at the end of the list, and insert is you can put it anywhere in between the list. There were two things. Similarly, remove and pop are two different things. In each of this method, next one which I am going to discuss now is pop. So what does this pop do? Pop is also going to remove the value from the list. But which value? For this I would like to just show you by a demo. There is one Pringles named chips, in which one single chips will be kept one above other. I have taken this my child's play toy. This is having, these are magnets. So I have taken three different things like this. Just assume it is there in the box. The first value which is entered is yellow. Then it's a box, okay, just like your Pringles chips, which can have only one. When you remove, it can only remove the uppermost one. So this is your right now at the bottom. Then you have given a purple. Can you all see? So let's suppose this is given one above the other. The third one is having a green. Okay. Now what exactly is a pop? Pop operation says that when you're stacking it up one above another, pop says the last one will be coming out first. We also call this as last in, first out. Okay, last in, first out. When you do your little bit of more in engineering, or let's say higher studies in computers, you will come to know about this particular algorithm which says LIFO, last in, first out. The other way around is first in, first out. Okay, this is one, you can just assume this as a one-sided closed cylinder. But if this cylinder was not, if this was open on the other side, then what happens? Whoever went in first will go out first. Yellow went in first, so it will go out first. Then purple will go. Then green will go. So that is a queue. That is an example of queue. If you are standing for a movie ticket, it is an example of queue, that is first in, first out. First whoever is coming in will get the ticket and go out of the queue. But if you are talking about keeping your books for correction before a teacher, whoever keeps at the last will get it corrected first. Why? Because the teacher will not put it upside down and then start correcting it, right? She'll take up whatever is there on the topmost. So that is called as stack. These are the two different algorithms which you have to know about. And right now, remember the word pop. It will remain same all through your computer languages and everywhere, because it's to do with algorithm. Pop says whichever has been last will be removed out. So now you can directly tell me what exactly will this pop give me. If I say L1 dot pop, what will it return back? Now I'll first mention what is pop. The pop method removes the last element or last value of the list. You have to remember just LIFO, last in will be first out. So if I'm saying pop, L1 dot pop, what should be removed? You all know the answer. Perfect. It is I. Now let me see whether it has really removed it or not. Yes, it has removed it. Okay, so this is your pop operation. In my college times, I had to write so many lines of code in order to get this pop done. And today you're getting such an handy one. Okay, give this dot pop and you get that removed out of your list. So this is your pop operation. Has everyone understood pop? Please, if you have any questions, I can take this algorithms as another topic of discussion, and I will surely conclude those different algorithms which are there in your uh, programming language. Now coming next to the reverse. Now what is reversing? You know it. Reverse means firstly agar initially it was q y I u, now it has to become u I y q. So we'll take the next method, the reverse method. Will reverse the list. Simple, as the name says. Most of the methods given here are reflecting what it does actually. So nothing much to think about. So when I say L1 dot reverse, that means you're reversing the list L1. Now what should it do? It has done it and kept it. You want to see it? You can see L1. Now your Q is, initially it was QIU, now it has become UIQ. That means your first element of the list is now going to be U, not Q. Right? So this is about reversing. One more algorithm which gives me a little bit of indigestion is sorting. Sorting also we had to write many lines of code in order to get one sorting done of an array or anything during our college times. Now what we do is we just say L1 dot sort. Now when I say L1 dot sort, has it sorted? Now there is a question for you guys. It says I Q U. What is this sorting? Why is I at the beginning? If you all remember, when I gave you ASCII codes, I have told you your initial capital letter A to Z will start from 65 onwards in the ASCII chart. So 65 is less than your small letter A, B, C starts from 97. So anyway, in any ways, your I becomes a smaller range of number than your small letter Q or anything else. So I becomes the first element here. It has sorted it. And your next number A, B, C, D, you all know. If you are going it alphabetically, your Q comes first, then your U. So it has sorted it like that. Fine. Again, if you have any questions with your capital letter I and Q and everything, please see to it that you refer to the previous video in which ASCII codes have been discussed. Okay. Now you also have something called sorted. If you see, this is what it is doing. L1 is L1 dot sort. When you're saying it has sorted and shown you. Now L1 is having this particular value. Suppose you want to retain this value in another list, then you can say L2 equals to L1. Okay, sorted of L1. Sorted of L1. Now when you say L2, the sorted list will be there in another list called L2. You may need it sometimes. You may want the sorted list to be kept and the original list also to be there. That time you can use this. Coming to the minimum, maximum and sum, which are the last three which I am going to discuss in today's session. How do we write? Unlike your previous commands what you have been using now, everywhere you have given the object name dot and the method name, or you can say list name dot the method or the function to be used. Here in this case, the last three ones which I'm going to discuss is maximum, minimum and sum. Now these three we are going to use directly as functions, and we will be passing and pass the list as argument. Now let's see what do I mean by saying that. You argument right. So suppose I want to say max of L1. It is saying U. Again, for those who are finding it really difficult to understand the character value and then understanding the ASCII codes, for them let me make another list called L3, or let's say num equals to, and I say any some number, few of numbers. Okay, and I'm closing it. Now I can say max of num. What should be the maximum of this? Everybody knows what is maximum and minimum. Maximum will be the highest value, minimum will be the lowest value. So what should this have? This should have 6523. Clear? And remember, this time I have passed the list as an argument to the function called max. Fine? I'm not saying num dot max. I'm saying max of and the num. Similarly, I can go for min. Min stands for your minimum. Remember, it's a keyword, so it is giving you in different color. Even sorted was in a different color because it's a keyword. It's a function, internal built-in function. If you can see, 23 is the smallest number amongst these, so this gives you the minimum of it. Now coming to the sum of it, you may find it difficult, however it's going to give you a right answer, so I'm going to give you sum of num, and I say enter. It is giving me 13,192. Anybody trying to question the computer can add it up and check out. Okay, so these are the few functions which we have covered in today's class, and in the next class, in the next session, I'm going to take up many examples, as many examples as possible, trying to use up these methods in my programming. Okay, until then, take care, goodbye, Jai Hind.